So big applause to Philip Bauer.
Thank you for
Would
that.
you manage
Who saw that?
nuclear
Franco?
emergencies with
Yeah.
Plone?
I owe you a beer. Okay. My name is Philip Bauer. I run a company called Staatsl.de with my two colleagues. I work with Plone since 2.1, and if you use Plone App content types, do migrations, work with relations, and so on, you probably use some of my work. So the question today is, would you manage nuclear emergencies with Plone? And the answer is probably no, unless you own a nuclear reactor, which I guess you don't. Germany does, though. It has nuclear reactors, or it had, because they're turned off, but they still exist and they still emit radiation. And countries need to be prepared for nuclear emergencies on their border. So imagine something. Now this is not working. Okay, whatever. Nothing ever works. So in Germany, there's the Federal Office for Radiation Protection, called BFS. And it is an institution of the federal government of Germany under the Ministry for Environment, Climate Action, Nature Conservation, and Nuclear Safety. And its job is to provide for the safety of people and the environment against damage due to ionizing and non-ionizing radiation. I'm not a physicist, so I have no idea what all of that exactly means. But one of the fields of ionizing radiation is handling radioactive substances in nuclear technology in all kinds of fields. And the protection against that and against enhanced natural radioactivity, like the Earth and like the mountains have radioactivity, and obviously the sun as well. So of special importance there is the defense against immediate hazards and precautions for the protection of the general public. So imagine something happens, maybe not this, but one of these. Like the last one is a bit disconcerting, but the others are totally within the realm of possibility. So in any of these radiological emergencies, the BFS comes into action. And as part of the Federal Radiological Situation Center, like a SITREP, like the war room in the Pentagon, not in the Pentagon, obviously, it coordinates nationwide environmental measurements, not measures, measurements, so it measures stuff, as well as conducting measurements of its own. So it tells people to measure and does it itself. So the BFS uses then these measurements, the results from these, and the information about the source of the radioactive released radioactivity to draw up a radiological situation report, SITREP called for us. And the radiological situation report compiles quite a number of different information. For example, stuff about the event itself, the measurements on a nationwide scale, measurements on a local scale, afflicted areas, then recommendations about what we should do on a small level and on a large level, and so on in a summary. But these recommendations then will lead to political decisions, to decisions to either inform, for example, the public to take iodium pills, to stay indoors, or to evacuate a certain area. And the difference between especially the last two, like please stay indoors or please get away from where you are a question of life and death. So the data in these recommendations, on which these recommendations is based, is changing with time, with new information coming in, with the wind direction changing, and so on. So the information that the public needs to be to the public then needs to be adapted to the situation at hand, while it is monitored closely. And even long after something actually happened, food for people and animals, the soil, plants, for example, milk, also needs to be measured for contamination. So I guess you now understand why it is important that the right information in this project reaches the right people in a controlled and timely manner so that they can make these decisions. And the tool to aggregate the information and produce and communicate the recommendations that are created then, that are decided upon then is Dogpool. And since Dogpool, you see it in the middle here, is built with Plone, Plone is actually used to manage nuclear emergencies in Germany. Dogpool is embedded in you already see that here, in a like a data kind of way, in a complex flow of information and decision making between various federal, state and local agencies. This is a very rough schema of what happens with the information. So there's measurements, predictions, and analysis going into ELAN. This is Dogpool called ELAN. I will show you why. And from that, we generate, or not, we generate information, measures, and results are generated and sent to over 70 institutions in Germany and also European institutions and our neighbors, Netherlands, France, Switzerland, for example. So Dogpool is a Plone Classic website currently running in Plone 6.1. It is open source and you can find the code on GitHub. Each time a release is deployed for the BFS, which is about every 1 to 2 months, the current code is synced to GitHub, so it's not 100% current. Development actually happens in our GitLab, like the Stassel GitLab. There is a version control system by BFS as well, so it's like mirrored 2 times. And tickets are managed in Redmine, hosted by BFS. But before we go into a lot of details of the application itself, we'll look at some history. So in 2000, a first HTML prototype for something to manage nuclear emergencies is created. I have no idea what it contained, some static websites. In 2002, something actually went online for internal, it's all internal use. So you actually can access it, but you can't get a login because it's not for an internal network, it's an open network, but you need to be logged in, not on a Plone level. So that actually went into use, a HTML JavaScript application, of which I sadly don't know much. That was way before my time there. And in 2005, a first version of ELAN, what ELAN is, I'll explain to you, went online, and that was implemented on top of ZOAP. In 2009, then ELAN version 2.0 went online, which used Plone 2.5, and it was developed by 2 people who were actually working at the BFS. So they chose Plone at that time so that they no longer depended on an external company. You see the irony, I'm an external company working for the BFS. But the idea was it should be open source and they're not dependent on one external company. So vendor lock-in was the main concern there. Plone was also very popular at that time, so there was a lot of support online to be had, for example. And they really like the do-it-yourself approach of Plone. So here at the bottom, you see the Portal Skins folder with these like archive option, archive content, add comment, like stuff that they use and wrote especially.
It's interesting, this was 2 years after Plone 3 was released.
Yeah, they were like lagging a bit. In 2011, ELAN E was intended for international use, was developed. So that's interesting. How did that happen? The IAEA, the International Atomic Energy Agency, evaluated a couple of systems for managing nuclear emergencies. And due to Plone being open source and Dogpool, it existed as a ready-made application already. Not Dogpool, ELAN, sorry. It was chosen over similar systems from the US, Norway, and Finland. Finland. So ELAN E was actually put in production in Romania, and I don't know what happened afterwards and why it never took over the national systems from Finland, for example, and the US and others. But for me, the benefits of sharing the burden of developing and maintaining a system of that complexity seems obvious. In 2013, a prototype based on Plone 4 for ELAN E was developed but never saw the light of day. It was also modernized and was part of a modernizing process. But then at that point, the idea that it should become more was born, and ELAN became only one of 4 applications united under the doc pool roof. That's like document pool, whatever, that's the name of it. The first one being the IMIS documentation system, which was then built in SOAP. IMIS RAI, also a SOAP application. ELAN, the thing I already told you about, running in Plone 2.5, and a web server that deployed static data called Rhodos. And in 2015, DocPool, that work was finished. These 4 applications were combined in one application. In 2018, it was upgraded to Plone 5.1. And this is, you see here, you can select the different applications. This is DocSys, ELAN, Rhodos, and there's more at the bottom. In 2019, Statzel, my company, came into the picture since the previous company, Condat, from Berlin, could no longer support the system. And obviously, it took us quite a while to get familiar with the large code base and the complex system that was under the hood there. But we managed to implement a couple of first features and, most importantly, performance improvements. There were real issues with performance, but we fixed a lot of these. And also, very early on, we were aware that we would need to migrate to Python 3 in the future to keep this thing running. Something obviously right up my alley. So in early 2022, we had the first version running on Python 3 with Plone 5.2. But as it says, 2025 here, it took quite a while to test the new version, iron out any kinks that were there. It's mostly manpower, the issues. Like BFS is a public institution, and if I say it's okay, that doesn't mean that they know it's okay. They just hear me saying that. And I may be wrong, obviously. So they need to test that, and that really, really takes some time. But finally, and also at the same time, we were always developing new features for the productive system. So it's like you have to sit on 2 horses at the same time, which is always hard. So finally, in January this year, we migrated and deployed the Python 3 version. And in August this year, we upgraded it to Plone 6.1. Currently, DocPool is used by 1,300 users from 70 international and national agencies and institutions. This will rise to about 5,000 in the future because of new requirements and new people having to use it in cases of emergency. The database is about 60 gigabytes at the moment, holds 40,000 entries, which does not mean there were 40,000 nuclear emergencies in Germany, but 40,000 measurements for a couple of emergencies that most of them did not happen in Germany, but elsewhere. But we'll get to that. We archive some data regularly, but as you can imagine, we cannot simply delete that stuff just because we like a small database. There's laws about that. So, as I said, DocPool consists of a couple of applications. There are 4 of them. They are interconnected. The main one being ELAN. It's Electronic Situation Display for the Management of Radiological Emergencies. There's all a German explanation for that acronym. And it manages the contents of a radiological emergency. There they are recorded, made available to relevant parties in a workflow process. So you can create an event, for example. You see that at the top. There's a test event and the Normalfall, which is like nothing's happening, with just business as usual. But this is not the production database, obviously. In reality, there's stuff about Saporica and whatever. There was something in Spain and other stuff happening. How do you call it? The satellites falling from the sky because they contain radioactive substances. So you create an event and then you can assign data to that event, so they are connected. The next one is RAI, which collects reports from the operators and the monitoring bodies of nuclear institutions, like reactors, and are made available to them to review them. There's also a law about that. for nuclear facilities. RODOS then is an application that manages calculations from the prognosis and decision support model called RODOS, real-time online decision support system for future, this is not measurements, these are predictions, future environmental contamination and the expected doses that these have to the affected population in a radiological emergency. So these are, you don't not only need to know what happened where, but also what will happen in 24 hours if the wind stays like the weather report says, and all this data is then generated by RODOS. Then there's DOCSIS, the most simple use case, which is basically you dump documents in it. They don't have any, like, they obviously have their internal use, but there's not a lot of logic and complex structure behind that. Important about all of that is that all content added to DocPool can be viewed in the context of more than one app. So it's not 4 different folders, it's all one thing. An example would be that an entry in the database in DocPool can be RODOS, which is like a prediction, but also an editor can then decide to assign this entry to ELAN, to an event that happens. So then this entry shows up in both applications, which is done via implicit filters for catalog searches that, for example, populate the navigation and search and listings and so on. So the data structure is that way that a doc pool is a container in Plone at the root level for each one of the states of Germany, for example, Bavaria, Lower Saxony, and so on. So each state has its own doc pool, plus there's one large doc pool at the federal level for the Bund. And each of these doc pools have one or more of these applications that are supported by this doc pool. Each doc pool, the container, has its own configuration and content, its own group management, users, and lots of settings. The content itself then is in group folders, often put there automatically via REST API, and a content in doc pool is called entry. That's why I used this word. Actually, we use REST API a lot to connect doc pool to other systems, to send in data and pull it out again. For example, also for public-facing systems, there's a geoportal. If you Google BFS geoportal, you find maps with lots of radiological data. So these entries in the groups folders are then displayed in listings that do not reflect the groups, but the category and the type of that content. For example, measurements for weather or water or mushrooms or whatnot. So an entry in doc pool is mostly a DP document. That is an all-purpose content type, dexterity content type. A DP document, so an entry, they come in various types, similar to categories. These types are defined by so-called doc types, document types. So an entry is a DP document that corresponds to a document type. For example, weather information. The point of this architecture is that managers can create document types as Plone content by hand themselves and configure it so that in a doc pool that they manage, so that then the users, the editors, can create entries of that type. So when the need arises for a new document type, we don't have to write a content type, a dexterity content type, but a DP document, a doc type of a new type, for example, Messergebnis Futtermittel, like food for animals. And then you can create entries based on that type. Then a group can be configured to be allowed to add such type of content, and the group folder can also be configured in such a way. These entries they then gain in configuration, from the document type. For example, if an entry can be commented on, if it should be published automatically, if it can and should be or automatically needs to be transferred to another state's doc pool, or which kind of view should be used when a user actually looks at that. The apps, Elan, Rai, Rhodos, and Doxys, are basically behaviors on entries of a certain document type. They are behaviors for the entries, but instance behaviors. I guess most of you know what a behavior is: a feature, usually one or more fields in the end, that can hold data and it can store data that are assigned to a content type. For example, an event has a start and end date, that's a behavior, or news items have images, it's a behavior. But in this case, we use instance behaviors. So on the other hand, compared to behaviors, the behavior is not applied to a portal type, so to all news items, but by item itself. So slightly simplified, there is a method called enumerate behaviors that looks in the schema cache for the behaviors that are assigned to this portal type. And in our version, it's not looking in the schema cache, but also at the item itself, where it says there's a collective add-on that does that. This is not used here, but the idea is similar. It's called collective instance behaviors, I think. So, for example, when Elan is activated, an entry has a field to assign the entry to an event. The Elan app has only 2 fields. Rai has 10 fields, and so on. So they're very different. And the doc type can define which app can be enabled for an entry of that type. That's like it takes a while to get your head around that architecture. So now, for example, the example from before makes a bit more sense. So when an entry is created and an app is enabled for that, the behavior is applied to that entry. So the entry can be Rhodos with the prediction. Someone comes in and says, oh, this can also be Elan. Then the editor loads again, and the field shows up because Dexterity finds this schema field then, because the behavior is there, and you can store data and assign that event to that data to an event that happened. Bit complex. For the migration to Plone 6 and also for the example content in the distribution, this proves to be a challenge. So if you ever have a system that uses instance behaviors, you need to know that you need to invalidate the cache to get that working. This is how you do that in collective export import, and in Plone export import, on the request there's a cache, on the object there's a cache, and also just you need to clear the schema cache. Otherwise, you'll lose data, which is not a good idea. I also already talked about the listings. So the listings that we have here, that actually are used by the users, are basically collections of entries of one specific type. So you don't see the navigation here, but this says Meldungen, like whatever, and then over here, Messdienstkoordination, that's basically the collection. So it shows all these kind of types. So members of groups can add entries of a specific document, of specific document types in their folders, and who can add what is controlled, I already said that, by group properties and properties of the folder. The entries are usually shown by event. So this is a filter, actually. This applies a filter on the listing. So if you switch the event, your listing or in the collection will be updated and changed. For most apps, we list the entries with relevant data like this. There's something you can expand. For Rai, we use EEA faceted navigation because we have so many fields and so much data to display. It makes it easier for the users to work with it. So one of the main tasks of DocPool is to allow the cooperation between stakeholders in different states of Germany and in different institutions. An important feature for that is to be able to transfer entries to other DocPools. So instead of sharing access to an entry, if someone needs that for some reason, you can transfer that to the other DocPool, and it will effectively create a copy of that entry in a target. There's like pre-generated target folders for that and stuff like that. But that whole thing poses a couple of challenges. One of the major flaws in this whole application from the very beginning was that events like radiological emergencies, Monday 16 hours, whatever, something happened, are actually located in the dog pool containers. So for example, something happens in Hamburg, it'll be created there. But when you consider that radiation does not respect borders or state boundaries, state lines, it becomes obvious that this is probably a poor decision, most likely driven by organizational needs for control and how to manage the data rather than for the desire to model the real life in a realistic way. So something happens in Hamburg, as I said, and the event is created in Hamburg, and then they realize, oh, this was not like a one street thingy, but a bit bigger. Then Lower Saxony gets the same event as well. So somebody has to create that there, and they need to be the same, which is kind of, weird. And so when the entry from Hamburg, an entry from Hamburg to Lower Saxony is transferred, then it needs to be assigned to the Lower Saxony version of the same event. So when the entry is transferred, the respective event needs to be either exist already. They actually check the ID in the past for that, like it needs to be the same ID, then we're good. Like test event, oh, this needs to be the same, probably the same test event, which is probably not it, it's not. Or it will be automatically created. As you might imagine, there are a couple of things that can go wrong there. But at least for DocPool, this will change soon and we'll switch to a centralized event management, which poses its own problems. Events, one example for that is events can be archived, which is another good feature because there's a lot of exercises and tests and you don't want them to clutter the user interface and the database, and so you need to archive them in some way. So for that, an event together with all its entries, which do not live inside an event, but in group folders, as you remember, are moved out of the regular content structure and put into special archive containers. There's a couple of challenges, as I said. There may be there's lots and lots of data created for that. So archiving will take some time. As you can imagine, moving a dexterity content type from A to B triggers reindexing. And if you have a lot of PDFs in there, like this will take a while or can take a while. Also, entries can be assigned to more than one event because, I don't know, some prediction, Rodor's prediction can be relevant for one event, but also for another, because the weather doesn't care if this event or this event is applied, is affected by that. So in that case, it means that the entry cannot be moved, but needs to be copied, effectively duplicating the data. We have something still active and another thing in an archive. So an event may be archived in one state doc pool, imagine that, but not in the other. Then what happens when you transfer entry from the one where it's not archived to the one where it's already archived? Do we again create another event for that on the target doc pool? And we have a couple of Spider-Mans in the same room. So a problem is that when thinking and discussing these kinds of data flow and problems, we often tend to forget that these things happen in the real world, and events actually happen only once and not twice. But the technical solution that we come up with does not maybe fit that model well, and always needs to be rechecked to see if it clashes with reality. And we and also the colleagues at BFS are sometimes so focused on, okay, we need a technical solution for this problem. We always need to step back and make sure we don't clash with reality. So when we move to a central event architecture, not all problems will disappear. For example, when archiving a then centralized event, including all data, will the entries of all states be moved to a centralized archive, or will each doc pool, each state in Germany get its own archive for only its data, and then actually effectively we have to copy the event again or not? So lots of things we can discuss and solve in the future for that. Most users read entries in DocPool using listings, which are basically collections. But when you click on an entry, you don't want to go into the group folder because then your navigation changes. So the view we have there is like a proxy view, so that it looks as if the object is actually inside that collection. So the URLs can be used and stays the same. That is, I really hate that feature from a data point of view, but it is super useful for users who don't want to be distracted by, okay, I found something and I clicked and now everything looks different. That's just horrible. And these situations are not fun. These are high pressure situations. They test for that regularly, but it's when something really happens, the stress levels can be really, really high. We use a distribution, Plone distribution, to provide example content for that. It's actually part of the repository for testing and training. And in the future, it will be redone. We started with this 2 weeks ago, used for exercises and trainings, exercises and tests conducted by the BFS and state institutions. And when I say exercise, I'm not talking about two people sitting in a room clicking on a mouse. I say there's actually helicopters flying in like expanding circles around nuclear reactors. And when it's an exercise, they take pre-generated fake measurements that they then send to systems that then feed it into dog pool. And the people they don't know where the wind is blowing while they're doing this exercise. So in 2023, I was in Bonn at the Beethoven Sprint, and I received a phone call from the BFS, and it appeared that during one of these exercises, it became clear to the people at the BFS that the user interface was too complex to handle in the high stress situation. So they decided we need a new user interface. Until now, as you already saw in the screenshot, we were still pretty close to the user interface of Plone Classic itself. And I've always been a fan of staying as close to the core of Plone as possible and as much as you can sell it to the user. Even with the, oh God, okay, I'll speed up. So we decided on various options, ignored. We creating a new GUI, and that's what we're doing. So we gained the time to actually develop a completely new user interface by migrating to 6.1, and we gained a lot of performance and usability. We added new features and stuff like that. So people are happy, and now we have time to develop a new GUI. And this is what it looks like. I wanted to give you a demo, but it's not that exciting. So it's a GUI for a tool to manage data. So the discussion obviously was, do we use Volto for that? And the answer is obviously no. Why is the answer no? Because not one single block would be used in this application. So Volto does not really make sense, even though like a lot, I do Volto a lot, but it doesn't make. It's not fun working with Plone if you're not allowed to use blocks. Volto. So, and also we can reuse a lot of the current code. We decided to use pattern slip to implement some fancy UI functionality. I wanted to show you a sneak preview, but I'm going to skip that. Believe me, pattern slip is really cool. It's shipped with Plone, and you can inject there's the inject pattern. Have you seen Hannes talk about the Ajaxify, which uses inject? This basically is filled with the inject pattern, and when you click on something, again inject pattern, and lots of injects, as you can imagine, which makes the thing really fast. So we started implementing the GUI, and Steffen, my colleague, found a really nice way to extract HTML from Figma. Actually, not extract, but Figma has an MCP server, and when you connect to that and prompt the LLM of your choice to use Bootstrap HTML, Vanilla JS, and so on, you can actually, component by component, get something really usable that you can then put in your templates, add Plone data and pattern slip functionality on top of that. Last but not least, what I really love about this project is not only open source, it's actually not only used by Germany. Currently, Austria and Romania are using or planning to use Dogpool. Romania was still using Plone 2.5, I'm not kidding you, at the beginning of this year, and they're just putting Plone 6.1 in production for their nuclear emergency data management system. And Austria is looped into the development of the new UI and are planning to replace that replace their outdated custom non-open source system with Dogpool next year. So how can that be? Because legal requirements and federal structures are completely different in all of these countries, obviously. But the way Dogpool is built on top of Plone and configured, I talked about the dog types, it allows to be used in far more than only one use case. Obviously, RAI, I think, is a very German thing because it's actually called after a law, which is called RAI. But ELAN it doesn't have to be used in multiple dog pools. If you only have a central government, you just use one dog pool and you create the groups through the web. You assign the types that you want to create through the web. You assign the measurement types that you want to create through the web, and so on. The apps actually are Python packages that you don't need to install, but you can install. And they are behaviors that you can enable not only on the item, but also on the dog pool itself. So when the behavior is enabled on the dog pool, you can not assign that dog pool to an event, but then content inside the dog pool can use that application, ELAN, RAI, orders, and so on. And also a lot of the data in there is tailored according to the IRIX standard, International Radiological Information Exchange, so it's interoperable with other systems in other countries. And so the BFS follows a open source strategy with that, without having had to convince them. And why is that? Because of this cute guy. This is komponentenorientierte Architektur mit langfristiger Ausrichtung. You saw that? That's the acronym, KOALA. They worked a long time on that. So they do keep it small and simple, which leads to good control and no duplication. They allow integration data exchange so that they are able to use. They use standardized modules to allow integration data exchange. They try to use innovative open source products. That's Plone. Which allows them to have no vendor lock-in and the application to be reused by other institutions. They power multiple use, which creates synergy, Austria, Germany. They work in small iterations and agile, which is obvious for continuous improvements. And if you don't have enough manpower, that also helps to say small iterations. You don't have to do that much at the same time. And they try to generate as much in-house know-how power to be flexible and responsive in emergencies. The future will hold the new unified event management, as I said, much improved demo content, Keycloak authentication, and obviously the new user interface, which is a really, really big work that we need to do there. And I'd like to expressively thank the team at the Bundesamt für Strahlenschutz, Katrin Probst, Marina Fabri, Peter Bieringer, and Marco Lechner. Wouldn't have been fun, wouldn't have been possible without them. And it still is, and it's a really nice example of public money, public code, and we as Staatsler, we're really, really happy to be a part of that, and we'll hopefully do that for the foreseeable future. Thank you.
Thank you, Philip. Because we have lunch next, we have time for one question, I think. But before that, what was the one Plone's feature that you are most proud of in this product?
The component architecture, I guess, altogether, which allows for non-spaghetti code flexibility.
I love that answer. Any other questions? Really?
So maybe one thing to think about if you ever talk to your government, the point to get them to use something like that is money, because doing that, using something like that is obviously much cheaper than developing and maintaining it yourself. But first you have to overcome the need for control, for absolute control, and individual egos. But if you overcome these two, then the sky's the limit. Then everyone can use that.
But first lunch.
Yeah, first lunch, and afterwards we conquer the earth.
And one more applause for Philip.
Thank you. Thank you.